So what we should get here when you solve this is that x equals 4. So that's the first thing that we want to look at, is our x value is a 4. And then yes or no, is this the midpoint? So the only way this would be the midpoint is if this is an 11 and this is an 11. We don't know that yet. That's what we now want to check. These would both have to be 11. So the way we can now do this is take this x value of 4 and plug it in right here. Well, isn't 5 times 4 20? 20 minus 2 would give us an 18. If I take a 4 and plug it in right here, 2 times 4 is 8. 8 minus 4 is a 4. So 18 and 4 make 22. Are each of those lengths the exact same? So B is not your midpoint. So we would say in this case, the answer to this is no. One was an length of 18, one was a length of 4. The only way that's the midpoint is if they're both 11. Okay. So we talked about midpoints. That's what we do with line segments, cutting those things in half. That one was not. We also talked about cutting an angle in half. So if we look at this next problem, we talk about angle ABC. So here's angle A. BC is the big angle, the full angle. So ABC is all of this here, the entire yellow region that I have shaded. And I tell you that that full angle is 46 degrees. All right, so this whole angle that I have shaded is 46 degrees. That's what this means. Then it says determine whether or not the ray, BT, is an angle bisector. So the only way that would be an angle bisector, what should happen in an angle bisector, is this segment or this ray should cut these in half. All right, so what should happen is if that is in fact an angle bisector, then 3x plus 13 and the angle 5x minus 7 would have to be equal to each other, just like it would at the top. No, don't do that. Sorry. We don't want, otherwise we're going to get that for sure. What has to happen is when we add these two guys up, the 3x plus the 13 plus the 5x minus a 7 would have to equal your 46. If we set them equal to each other, we're going to guarantee that those guys are x's. So add them up. They've got to equal 46. Combine your like terms. 8x plus a 6 equals 46. Subtract your 6 over, and we should get x to be a 5. So that's good. Now determine if this is in fact an angle bisector. If this is an angle bisector, then this angle should have gotten cut directly in half. This better be a 23-degree angle, and this angle here better be a 23-degree angle if this was in fact cutting a 46-degree angle in half. So take your 5 now and plug it in. 3 times 5 is 15 plus 13. What we find is this angle was not 23 degrees. This angle was 28 degrees. That's this angle. So right away we know this is not, but let's confirm this with our next one. This should have been 23, but if I take 5 and plug it in, 25 minus 7 is 18 degrees. So that did not cut that 46-degree angle in half and create 223. Let me make this bigger for people. There we go. All right. So that also, we would say, is a big fat no. All right. All right. So that's that. Midpoints should cut a segment in half. An angle bisector should be cutting an angle in half. All right. So those are some words that we talked about at the beginning of 5.3. All right, similar things here. I made you draw your own pictures. So it says draw a picture to model each situation. So the first one is M is the midpoint of RT. So we want to draw the segment RT first. So we talked about how this thing doesn't have any arrows at the top. So R to T is a segment. And I am telling you that M is in fact the middle point. So it's going to cut that segment in half. I want you to find all three lengths, R to M, M to T, and then R to T, if R to M is 13x minus a 7. So this segment here is 13x minus a7. And then m to t is 9x plus 17. Unlike number 1, when I was asking you if it was a midpoint, number 3 is telling you it is a midpoint. It is with 100% certainty when I make the statement right here, then that is your midpoint. Because it is a midpoint, these two segments must be the same length. So now is when we know they're a midpoint. That's when we can set them equal to each other. We then go through and solve this. So we get 4x minus a 7 equals 17. And again, I'm going to go through these kind of quick. You guys have proven to be pretty good at solving equations once we have them set up. We should get our x to be a 6. Notice how I don't ask for x at all. So while x is nice, it's not our answer. So tomorrow you're going to have a bunch of multiple choice questions. Don't be picking 6. All right, if this was your question, 6 is not the answer. What we now want to do is take 6 and use them to find these 3 lengths over here. So if I go to Rm, take your 6 and you're going to plug in 6. So what is, ooh, that's not an easy one. 13 times 6 is what? 1878? Anybody had a calculator want to confirm that? Should be 78, right? Good. And then subtract 7. So this should be 71. So we know R to M is 71. Now I would check MT better be 71 also, right? But when we did our own work, we might just want to throw it in there to confirm it. All right, it better be 71. It's a nice little check. So let's go ahead and take this, plug it in also. 9 times 6 would be 54. And then when we see that 54 plus 17 does in fact equal 71, then we know we're good. We didn't mess up. Everything worked out nicely. R to T is the full length. So it's from the beginning to the end. So it's 71 and 71 together. So that's 142. All right. 4, similar idea, just an angle bisector. So this one is now going to ask you to draw angle ABC. So similar to the one that we did earlier. So just draw an angle. Doesn't matter how big it is and wide. It won't necessarily matter. So then let's put A up here. B must be your vertex. And then C is going to be down here. Then what you're going to do is draw a ray that starts at B and goes through the point D. That's going to cut this angle here in half. So this is our current angle. We want to cut this angle in half by drawing in a ray that starts at B and then goes through D forever. So it should look something like this. And then we're going to put D somewhere on that ray. Like number 2, I was asking you, is this an angle bisector? You were supposed to determine if it was an angle bisector in number 2. Number 4, I am flat out telling you that that angle is going to get cut in half. So that absolutely cuts this angle in half. So when we then look, angle DBC, the measure of angle DBC is 6x plus 17. So that's going to go right there. It's bigger yet. And then ABD, too big, is 8x plus 3. So ABD, 8x plus a3. Since we are told that this angle has gotten cut right in half, that means those two have to be equal to each other. So once again, since we know these are getting cut in half, that means each one of them has the same degree measure. Set them equal. Here I do want x, all right? So x is going to be a 7. And then answer the second part just to make sure we understand what we need to do to get that one. So now the only other thing I want to identify is what's the measure of angle ABC. All right. ABC should be the big entire yellow shaded region, not each individual one. All right, so Cam, what'd you come up with for that, Cam? Good. Take the 7, plug it into both of these. What does each of those give us? Good. Each one of those gives us a 15.9-degree angle here, 15.9-degree angle here. So all together, what'd you say again? Good. So it should be a 118-degree angle overall. All right. So that's a little bit of the stuff that we did a while ago. Okay, probably it's been 2 weeks since we kind of dove into those things to make sure we can handle that. Then a lot of our time recently has been all of these. All right, so 5.4 then was just identifying what all of these are. So let's see if we can now do these. If I ask you to identify any alternate interior angles, all right, so it says for problems number 5 through 8, line A is parallel to line B. State the pair of angles that represent the following. So write down a couple of alternate interior angles, and these are always got to be formed by two lines. So here's our two lines that get cut by a third line, which we call a transversal. So that's this one. All right, so Cam, what's one set of alternate interior angles? Angle 2 and angle 8. All right, so this angle here and here, they're both inside and on opposite sides, which would mean the other one would be what, Cam? Good. Angle 3 and angle 5 are alternate interior. All right, if we go same side, so now that need to be on the same side of the transversal, but also be inside. So again, here's our inside. If I shade all of these in. So now, Jenna, what is one set of same side interior angles? Good. So she said angle 3 and angle 8. All right, so here and here, they're on the same side of the transversal. They're both inside, which means the other one is what, Jenna? Good. Angle 2 and angle 5. Next set. Again, to me, over the years, these are the ones that people tend to not see quite as easily as the others. So these are our corresponding angles. This now takes into account, here are the 4 angles that we create with the first intersection. Here are the 4 angles that we create with the second intersection. Corresponding angles mean, notice how we have 4 different corners, kind of. We want the correct corners to match up. So here is when we kind of have a lot of them. So see how angle 1 is this upper left-hand corner of these 4? Well, that corresponds to 5 in the blue angles. So angle 1 and angle 5 are corresponding. Of the yellow angles, 4 is the upper right side, 8 is the upper right side. So we're going to do angle 4 and angle 8. We have a bunch of these. Lower left-hand corners are 2 and 6. So we're going to squeeze a 2 and a 6 in here. And then the last one, bottom right, is 3 and 7. So angle 3 and angle 7 are our correspondings. All right. Then finally, alternate exterior angles. If I once again shade in what's inside, we don't want any of those angles because they have to be exterior angles. Alternate means we want them on the opposite side of the transversal. So if I look at the yellow angle up here, Cam, angle 1 would be an alternate exterior angle. Uh-oh, it just disappeared on me for some reason. Why did that just happen? That's usually not a good sign. Oh, what's it even look like? Where's the 7 at? Is it 7, 8 right here? This is how it's on your sheet? Or, okay. This? One, 5, 4. Yeah, 4, 8 has to be here, right? Because they're corresponding. Oh, now they're back. What the? Okay, let's try this again. Hopefully they'll stick around a little while. All right, So alternate exterior, angle 1 is an exterior. 6 and 7 are exterior. 7 is the one that's on the opposite side. So we should have had angle 1 and 7. Now they disappeared again. Don't ask me where these are going. And then angle 2 would be whatever I had down here, what was corresponding to 3, 7. So what's going on? Jeez. All right, let's hurry up and do this while they're up there. So angle 1 and angle 7 was good. So we have that, right? And then angle 4 and angle 6. All right, those should be alternate exterior angles. All right. All right, then these guys. This was your homework last night. So again, we're going to kind of set these up. Actually, here's what we're going to do. Go to the last 4 problems because this was your homework the last few nights. Go to the last 4 because this is one we haven't done in a little while. So just jump to these real quick. And let's do a quick little review of these. This is actually right out of an assignment that I had given you. Let's see if we remember these. And then if we have time, we'll go back to the previous page, but those I'm going to hope we just have been spending a lot of time on those that we're good with. So it says you're just going to match these up. We have our 4 different phrases. So perpendicular bisector, median, angle bisector, and then an altitude. When we do these, there's a lot of different ways to kind of go through this, but the median to me is the easiest one. Right? I think it's probably the most common one that's currently in our vocabulary. You would have dealt with medians in many different ways. When you did statistics, that's the middle number. When, the median of a road, all right, all means the same thing. We're looking for the one that extends from the vertex. So it has to come from the vertex. And then it cuts the opposite side in half. So find the one that does that. We have a line that's extending from a vertex, and then it goes to the opposite side and cuts it directly in half. So when we do that, which number, 23, 24, 25, or 26, so which of these should we be putting that B on? All right, that's kind of what we're doing. We're just matching these up. All right. Hopefully, as we look at this, if we look at number 25, notice how this line comes from the vertex, it draws into the opposite side, and then the tick marks, remember, tick marks tell us that we have congruencies. Since those 2 little segments are congruent, that means this is the midpoint. So number 25 is your median. So you're going to put the B right there. All right. And then we're done with this. So we're a little process of elimination. Go ahead and fill them in. Honestly, I don't know how you're going to see these. Go ahead and put them in. I don't want to tell you what is easiest for me to see, maybe. Fill in the rest of the 3. We've at least narrowed one of them down. Think about what the words mean and see if we can put them in the right order then. All right, let's now see what we have settled on. So however you thought this through, totally fine. Keep that thought in your head. To me, the next one that I think, and see if you got the same exact thing, the next one that's kind of the nicest is what we call a perpendicular bisector, because we're not just looking for one thing, we're looking for 2 things. It has to be perpendicular. Notice how number 23 is telling us that we have something perpendicular, as is number 26. So a perpendicular bisector is either 23 or 26. The nice thing about a perpendicular bisector, you also have to bisect that side. So if we then look at 23 and we look at 26, the one that's getting bisected as well with the other side, or that is bisecting the other side, is number 26. Not only do we have a 90-degree angle, we are told that these 2 lengths are the same, or the same lengths anyway. That means that side got bisected. So number 26 should have been A. And then we're done with perpendicular bisector. Angle bisector, we've talked about it a little bit today. Of the two, really of all of them, we use little arcs to indicate angles are congruent. So if you look at number 24, notice how this line is creating two angles that are congruent. So this line right here creates two angles that are ultimately congruent. So number 24 has to be our angle bisector. And then all an altitude does is creates a 90-degree angle with the opposite side, and it has to come from the vertex. So that's this one. Vertex to the opposite side, we're forming this 90-degree angle. So we should have actually just gone in the opposite order there, D, C, B, A. All right. There's a question very, very similar to this tomorrow where you're just going to match, understand what they are. All right, so please make note of those. Please make sure we have this. You have your notes. Just look at them. This question, if we don't get to it, which we probably won't, should look familiar to you. I would try this before you come in. That's the little extra credit quiz that I gave you last Friday. So if you want to see what those answers are, I'm going to leave you those. Let's hop up here. Let's do a few of these, and then hopefully we're ready to go tomorrow. So when it tells you, given the parallel lines, and the lines we know that are parallel are the ones that have the arrows on them. So if we look at the ones that are the arrows here, here, and then here, we know those are parallel. Then we want to use that idea to find our x or our y value. So if we look, here's the interior. Notice how those two angles that I gave you, 52 and 15x plus 8, what those are same side interior angles. There is no reason not tomorrow to know if those are congruent or supplementary. We have those written out in your packet, in your notes, in multiple places. So you can reference those real quick tomorrow to know, are we setting those equal to each other, or are we adding them up, setting them equal to 180? And what you should find, same side interior angles are supplementary. So because of that, that means we want to add these and set them equal to 180 degrees. All right. And then we'd solve this. Make sure I did that right. Brush too much. Yeah. And then 15x should equal 120. Oh no, is that going there good? 8. Okay, good. Yeah, so 8. X equals 8. If you get a decimal, don't think it's wrong necessarily. I kind of feel like I fall into that trap a little bit. Decimals are okay, but usually we try to give you some nice numbers so you don't have to worry about that too much. When we go to number 10, if we look at these 4 angles up here, and then these 4 angles down here, and we start thinking, all right, well, here's the inside. One of them is inside, one of them is outside. The only thing we're really left with is the idea that these are both the upper left-hand corners of those 4 sets of angles. So these are corresponding angles. So again, if we can identify what type you're dealing with, corresponding in this case, you have this written down in multiple spots in your notes. You can then look, all right, am I adding these up, setting them equal to 180 like I did in number 9 because they were supplementary, or are these congruent and I'm going to set them equal? And what we should find is that corresponding angles are congruent. So that means we're taking that 136, we're going to set it equal to the 6x minus 8. There's your equation. That's what we're going to go through and solve. What is that, 24? And then x equals 24. All right. Let's see here. Yeah, let's do one with the x and the y. We'll do one of these and probably have to call it a day here. Because now you need to be a little bit, and when we have x's and y's, we need to be a little more systematic to make sure that we solve these. Actually, so let's just finish with 11. Start number 11. There's really, I look at, there's 2 different ways that jump out to me to handle this from the beginning. Both are equally correct. So whatever way you see first, do it. All right, Cam, what was your thought? Which one? Alternate interior. Good. So he went with the 5Y and the 80, and he saw that those were alternate interior. And what's true about alternate interior? Good. So that means we can set those equal to each other, and then we can solve that, and we get 16, right, Cam? All right. So now if I know that the y is a 16, that's if we got y first. How could we have solved for x first? Anybody do that one first? Yeah, Ahmed, what'd you do to get y first? Good. So what Ahmed said, you probably couldn't hear him. He talked about how these guys are same side interior angles. So he solved for x first because he knew those are same side interior. Same side interior are supplementary. So those guys added up had to equal 180. So then he solved it that way. And you get 10, Ahmed. And he got x equal to 10. So just different ways of viewing it, different ways of seeing it. Both of them are valid. Tomorrow, I do want to do one or two of these. So right at the beginning of class tomorrow, we'll talk about, one or two of these guys to make sure we understand what this question is asking. But other than that, hopefully we're good. If you have any issues, hop on the link a little bit early. Mr. Kubowitz and I are usually hopping onto this at 9:20 to 9:25. There's a few minutes in there if you want a question to get answered where we would be here and you wouldn't have to worry about asking in front of everybody or taking the quiz without knowing something. Okay. So look this over. This is the material you need to know for your quiz tomorrow. And then hopefully this one will go a little bit better than our previous one, which is a little bit sketchy. All right. There's the bell. We'll see you guys. Have a good day. It's 35 minutes is not enough, Ahmed. Bye, Jenna. Thank you. You too.